Is it okay? Can you see my screen? Okay. So for the first keynote presentation, we are glad to present Professor Guy Fournier, who is affiliated professor to Pforzheim University in Germany, as well as the Industrial Engineering Lab at Saint-Tropez in Paris. Guy's core interests are within international economy, sustainable mobility and development, and new innovative business models, particularly with the electric vehicles and autonomous vehicles. Guy is currently working on a Horizon project to design and carry out a full-scale test of urban automated vehicles in 4 European cities. So thank you, Guy, for being a part of this session, and I'll leave you the mic to you.
Yes.
Stop sharing this one.
It's my turn, right?
Yes.
Yes. So first I will share my screen. Can you see it? Yes, okay, perfect. So, okay, so thank you very much for introducing me. It's a pleasure to be here today and to share my experience about Mars and automated vehicles. Today, I would like to speak about how to shape a mobility of the future, which serves a general interest. Potential emerging mobility services with automated vehicles and their related ecosystems in city. This research is a part of a European project. This is an avenue project. It's called. It's H22 project about with 20 million of budget in 16 European with 16 European partners and 7 countries. What we are doing, we are implementing automated vehicles for public transportation in Lyon, in Geneva, in Luxembourg, and in Copenhagen. And so one of, when we started, so the aim is to look after the impact of automated vehicles. So we are responsible for the social, economic, environmental, and sustainable impact of automated vehicles. So when we started, we first were looking to the automated vehicles. So we had a technological approach. So it was about technological assessment. But very fast, we were seeing that it is not enough and that depending on the definition of the system, if you're just looking a vehicle or if you're looking a city, you can get completely different impacts. And that's the reason why we decided to integrate the platform economy and digitalization on one side. And we have seen in a second point that the integration of automated vehicles can be a game changer for transport in cities. That's the reason why we will focus first on the principles of the internet economy and urban transport. Then in a second step, we will look together which are the emerging mobility services with automated vehicles. And afterwards, we will have an evaluation or impact assessment about the potential effects of emerging mobility services with automated vehicles. Now, let's start with the principles of the internet economy and urban transport. So first of all, I would like to start with the characteristics of these new business models. And the easiest, and this is most of you will probably know, it's economies of scale. So economies of scale is when you have more output, it is possible to have a less marginal cost for each additional product you are producing. That's linked with the fixed cost. But with the digital economy, it's completely different. With the digital economy, when you have a PDF, for instance, you would like to share this PDF. So the costs are, on contrary to, let's say, producing a car, it is very few or zero. That's the reason why the marginal costs are near to zero. And in the transport, now making a link to the transport, we have the open data, which can be static and dynamic. which can be diffused at very low cost as well. So what are static and dynamic data? The static data are when we are speaking about when is coming a train at what time and what, for instance, and when we are speaking about dynamic data, it's about if this train is too late or the bus and so on. So these data can now be diffused to very low cost. Then the second characteristic of the new digital economy is the economies of scope. So the economy of scope, this means with a growing number of products or of platforms, the costs are decreasing. So I would like to give you an example with Amazon. Amazon, for instance, has started with selling books on internet. So adding now additionally to books, the selling of devices, so electronic devices, it's not more expensive. So the price are the same. So this is typically an economy of scope. If you're comparing this to the traditional economy, so if you have producing one car, you would like to produce another type of car, it's completely different. So we have no economies of scope. In the internet economy or in the transport economy, you can have so-called economies of substitution. I would like to give you an example with Uber Eats. So you know probably all Uber. This is a ride-hailing mobility service provider. And they have decided because of COVID to extend their business and to create food delivery with Uber Eats. So they were taking exactly the same software, the same driver. And so these are typical economies of substitution. And this way it was possible to use Uber for Uber Eats. And so the costs are not very high, Let's continue with the third characteristic. It's called network effects. So these are very important because this is linked with external effects we will see later to evaluate this transport systems. So what are network effects? So this means with each additional user, the value of the marginal utility, so the value for the user is growing. I would like to give you two examples. The first one is BlaBlaCar. So if you have BlaBlaCar, everybody of you is aware about BlaBlaCar. So when you have 100 user, or if you have 1 million user, it's completely different. So the chance to go from one place from A to B is much higher when you have 1 million user than when you have just 10 or 100 user. So this is a typical network effect, which each additional user, the value for the user is growing. Another example is Uber. So here it's the case when you have more travelers, so more travelers attract more drivers. These drivers attract more travelers who attract more drivers as well. So you have something like a circulus virtuosis, so a positive external effect, which is one of the typical characteristics for digital economy. But beside these number of members and users, we have also another point. We have also the number of means of transport and their related combination. In fact, the idea behind this is to have an integration of the mobility offers in one click. So the benefits are that it is possible to increase the choice of available means of transport in one application. And on the other side, it is possible to enable different combination of complementary means of transport of all private and public transport operator to one trip. You can this way individualize the transport. This means what are the effects then for the passenger? So the marginal utility is growing for the passenger on one side because the offer is much more attractive. It can be individual on one side. On the other side, it is more attractive for the transport operator. For instance, it is possible to get open seats in private and public vehicles, but also, for instance, for individual vehicles, if you are making car sharing. And you have also better informed passengers. Then the transport system as a whole is getting better because you have a better understanding of the behavior of passengers, and you have more complementary between means of transport, and then more competition and innovation, and finally cost savings. But now we would like to introduce the concept to say, what is the link with automated vehicles? Well, automated vehicles could be a game changer with on-demand and door-to-door features. So this is what we're doing in our European project. And this way we could better fulfill individual mobility needs of the passengers. Let's come to the last characteristic of the new digital business models, and this is called the lock-in effects. Lock-in effects means when you have high costs for changing the system, that high costs for changing the system ensures customer loyalty. Here we have a customer and an ecosystem. And the customer is attracted by a customer-centric approach, which is used by, let's say, Amazon, Google, and so on, and also through innovation or technology and so on. Now, if you decide to change to go to a competitive ecosystem, in fact, most of us are not doing this because you are locked in through switching costs. So you're not changing because the cost of searching are too high, or you have invested in your ecosystem. I have, for instance, in Apple, I have invested a lot in dictionaries, so I would not like to lose these costs for these dictionaries. Or we have learning costs, or you have also habits, so you don't want to change because you're now used to use an Apple iPhone, and that's the reason why you're not switching. To summarize, these four characteristics, so economies of scale, economies of scope, network effects, and lock-in effects, can create, make it possible to have the driver to better meet the needs of the user. On the other side, we can create value and for the stakeholders, so for the citizen, for the public transport operator, and also for, of course, for the society. But we have also a point which is very important. We have the so-called winner takes it all effect. This means that when you're reaching a critical mass, this can lead to a dominant position on the market through setting standards. And this way you have a distortion on the market with the competitor, with the supplier, and also with the customer. With the competitor, you have high entry costs to provide an own ecosystem. So this means we have now something like a monopoly. So the competitor is not able anymore, if he's the loser, he's not able anymore to integrate, to build up a competitive ecosystem. And so this obliged the competitor to integrate the ecosystem of the winner. And this way he will provide product and customer information to the ecosystem provider. And he can adapt his strategy and this way also consolidate its position. So this means he can also lock out the competitor from the ecosystem. On the side of the supplier, you can have afterwards a so-called preferred partner, and it's not in terms of transport, it is important to have so many means of transport than possible. And for the customer, you have, because of the increased switching cost through locking effects, you have less choice. So the shaper of the ecosystem can thus capture more value to consolidate and cement its position on the market and create dependencies. Now, let's have a look. How can you integrate the concept of digital economy with automated vehicles? So let's start with the current situation. So the current situation is unimodal. We have several individual means of transport, like a bicycle, individual car, walking, or a scooter on one side. And on the other side, we have private and public transport provider with a singular ticketing. So in the future, the significance of mass models should thus increase, since all means of transport will complement each other and create added value for the customer. Now, the question is how to integrate automated vehicles in a future transport system in a city. So the first idea is to have individual vehicles which are automated. So this is, of course, the first thing everybody is thinking about. But the problem is it is very expensive. So you have to think about 100 or 200,000 additional euro for this kind of vehicle. And thus it is just a marginal market for the future and a marginal solution for the future. The second point, this is much more interesting, is using automated robotaxis. So using a fleet of vehicles which can offer mobility as a service. And then the third solution, this is the solution we are working on the European level, is using automated e-minibuses, which are integrated or have to be integrated with other means of transport. The advantage of this approach is to have individualized public transport, and which can be an alternative to individual vehicles. But it is this system is more efficient and have less negative externalities. Now, I would like to deepen the model one. So this will be based on automated robotaxis, and then I will develop three models for the with automated e-minibuses. Let's start with the first model. In this case, we have automated robotaxis here with their own ecosystem. This is here in yellow. And on the other side, we have public transport platform where open data, this is what you can see here, are provided and then coming back. And this way, it's possible to combine different means of public transport in one trip. And you can see here in this small picture that it is of course better than 10 years ago, but it is still a poor offer in comparison to automated robotaxis, where you can go from one to B. And this is, of course, very convenient. But this model is perhaps interesting, and it is so interesting that it is, we can see, for instance, in particular in the United States, the displacement of public transport. So this attractivity of automated taxi or Uber, for instance, is so attractive that it is a threat for the public transport, and thus external will have more crowded cities and more vehicles and so on. The second model is based on, so in this case, we have the integrator of the mass is the private transport platform. So because it is obligatory in the European Union, so we have open data from the public transport platform. These open data are coming here, and then it's going back for the public transport platform on one side, and on the other side for the private transport platform. But you can see here, the private transport platform can provide a much better offer, because it can mix the means of transport from the public platform on one side and from the private transport platform as well. This means you have information asymmetry between the private and the public transport platform, and at the end, the private transport platform will be the winner. So it is a less effective and sustainable model, increasing external cost. And you have also the problem of displacement of the public transport. Then we have another type. I'm still starting with open data. So where are the data coming from? So the public transport platform is providing all the data from the buses and trains and so on. And the private transport platform has to provide these data as well. So, private Uber or all do not want to provide these data. So, but the state can, of course, oblige these private companies to provide these data, and then we could have a very good offer on means of transport and use the external effects of complementary. You can use the positive effects of using complementary means of transport. So this is a very effective and sustainable model to support public welfare without favoring public transport. Then we have the last model. It is public and private transport as integrator. In this case, the data are provided from the public transport platform and from the private transport platform as well. And these data are shared to both transport platforms. This means you would have a fully integrated market with fair competition or co-opetition in this case. So this is probably the most effective and sustainable model with the highest public welfare without favoring private or public transport. Now, how can we now integrate all these different models? So the potential effects are summarized here in this table. In this table, you can see the 4 different models on the top. So robocabs, private transport as modality integrator, the model 3, public transport as modality integrator, and public and private transport provider as mobility integrator on one side. Then we have on the other side the characteristics, so mass level between 0 and 4. So 4 means that you're following societal goals, for instance, and 0, you have no modality integration. And then if you're looking further to the potential impact, so economies of scale, economies of scope, network effects, and lock-in effects, you can see that the best model is probably the model 4, where you have a high level of economies of scope, you have a high level of network effects, we have low level of lock-in effects, and you have high level of economies of scale. Now, how can we conclude? First of all, we can say that automated vehicles and mass models can be a game changer for the future of transport in cities and enable huge positive externalities. So we can create, let's say, a positive economy or commons. The rules on the European, national, and local level are the key to enable a governance model which serves and safeguards general interest. So this means that regulation authorities will decide about the legal framework and thus about the mass model and their related effects. This means at the same time that we need another strategy for making regulation and making laws. So we need to be very fast and innovative. And in fact, probably we have 2 approaches. We can have an ex ante approach. This means, let's say in this case about automated vehicles and mass. So the windows of opportunity for avoiding facts is very short. And you have ex post approach. And this means when through the lock-in effects and the creation of a monopoly of, let's say, a private provider, mobility provider, so it's much more difficult for the state to change than the facts. And finally, I have to add, and this is a very important issue, we need also regulation for the standards. And I mean open data and APIs, and because these are the prerequisites to allow the wished effects. So why is it so important? So open data are very important to know where is the mean of transport and when is it available. So to make it possible to combine all different means of transport to one trip. On the other side, the APIs, this is more for interoperability of the different vehicles. So it is important to know that the mobility platform is compatible to automated vehicles, and that's the reason why you need norms for this. So I would like to, I'm on time, to thank you very much for your attention, and I'm very glad to hear your your question.
Thank you so much, Guy, for this presentation. Regarding the questions probably that are coming, I have one initial question regarding the individualization of this public transport of automated vehicles. Just up to which point we are talking about individualizing public transportation, and up to which point this is going to take us further in the path towards sustainability.
So you mean when this will happen, right?
Most of all, I mean, when we are talking about automated shuttles or vehicles and individualizing public transport services, I wonder if we should be also trying to balance how individualized this is going to become or not, since the principle of public transportation is mostly mass transport.
No, it is not mass transport. So public transport, mass transport is a combination of private and public transport. So it is looking the best and to give to the user or the passenger the choice of choosing the combination of different means of transport, depending, for instance, on the cost or on the time you need, or if it can be comfortable or whatever.
Yeah, I meant mass as not mass. It's complicated to say mass without referring to mobility as a service, but I meant like massive transportation of people. But yes, okay, great. I see. You say, let me check in. We have a question from Flor. Is there already an evidence of the emerging model type 4 nowadays?
Yes, if I'm going back to here, you can see here on the back we have the legend, and you can see model 4. We have no, it is not existing. So the step 3 is existing in Helsinki, for instance, and in Hanover. So we are a lot of cities are working on it and trying to implement it. But for the step 4, until yet, it is not possible anywhere to integrate automated vehicles in a mass. So what we are doing in our European project, we are making mobility on demand and mobility and door-to-door. This is for the first time, I will probably in the world. So it will be officially started in a few weeks. I don't know exactly when, it depends on COVID. So then the next step is probably to integrate this in a mass. So it's not existing yet. So let's say we can think about how with the best way to manage and to design this.
Thank you, Guy. Very well. Another question would be, what do you think about what would be the outcome of a similar program being implemented in the French context?
To my opinion, this is not. Yes, I think in Paris we could. It could be a very good opportunity to try to implement this. The know-how is there. You have companies who are making mass platform. You have companies producing automated minibuses. So I think you have good yes, good conditions to realize it.
And I think there was Tommaso who had a question too. I don't know if he's still here.
Yes.
Okay.
Okay.
Thank you.
Didn't have the time to write it down. Two questions very quickly is, when we see Uber, which has 90 billion capital evaluation, 12 billion net revenue and 9 billion losses in 2019. I mean, is this a sustainable business model for the future of mobility? I know that is a provocative question, but I would like to have your point on that. And my second point—
Can you give an answer immediately?
Sorry?
Yes, I can give you an answer to this question. And
Yes.
then come to the second. Yeah. Okay.
Oh,
Very easy.
Okay.
So in fact, it's like Tesla. So it depends on the value on the capital market. So if the capital market gives a value of, you said, 90 billion of euros. So let's have a look to Renault. It's just 12 billion. So you see, this means that the market believes in this future, even if they're not making money today.
But we should believe it. Is that sustainable? I mean, is not that a debate that we should have when we bet on a business model that it's, I mean, there are a lot of economists who suggest that this is just a huge speculative bubble. I'm not saying that this is, but I mean, should we debate it or not? This is a question I would like to make to you. And the second point is that is the main benefit of automated transports the fact that we share vehicles, and so that we use less individual vehicles. So why, I mean, why we should move, this is another provocative question, to automate vehicles?
It is not provocative, it's a very good question.
Rather than sharing our vehicles,
yes,
in other ways.
So to me, it's a very good question. So within our project, we are making a representative surveys. You know, it's not a user survey, it's a representative survey. And we are asking exactly this point. And what it is very interesting for us as a result, so it is, we are going to publish this in the next month, is that the people are ready to give up their car if they have the choice to have individual transport. So if this is working, in fact, the people would like to have an individual answer for their mobility needs. With the individual car, they can take their car when they will and go somewhere. And if we are able with mass and with automated vehicles to provide something similar, people are ready to give up to 50% from the strong, let's say, the strong individual vehicle driver. They are ready, 50% of them are ready to give up their car. And I think this is really a lot.
Thank you.
You're welcome.
Thank you so much also for those questions. Okay, very well. If there are not further questions, we do have then, thank you so much, Guy, for this amazing
You're
presentation.
welcome.
There's so many new data here. We are going then to take a break before going to the next keynote, if that's okay for you. So we'll take this 15-minute break and we'll see you at 3.
Oh no, 5 minutes. 5-minute break.
Oh, okay.
Just have a 5-minute break and the next keynote starts at 2:45.
All right, then see you in a bit.